Hello everyone. In this session, we will discuss about how to write a complex number in trigonometry form or polar form. Shall we start? देखो. So trigonometry form of a complex number. ता पूर्व suppose one number is 1. I will take a number 1. So what is the trigonometry form of this number? Can I write this one is equal to sine pi by 2 or cos 0. So these are the trigonometry form of this real number 1. Similarly, today we will write the trigonometry form of a complex number. Again, 1 is also a complex number. The complex form of this number 1 can written as 1 plus I 0. Right? Here 1 is the real part and 0 is the imaginary part. We have already discussed in our previous session. In today's session, how to write this complex number in trigonometric form or polar form. Right? So let us consider a complex number in its standard form as x plus I y. This is the standard form of a complex number. It will be denoted as z. Z is equal to x plus I y. Now I will write this complex number in trigonometric form. So first, let us draw this complex number in a complex plane or organ plane. X-axis, y-axis. In coordinate system, we call it x-axis and y-axis. When we discuss or draw this complex number in a plane, this plane is called complex plane or organ plane. This is real axis. This is imaginary axis. So the real part of a complex number we will draw in real axis and imaginary part of complex number we will draw in imaginary axis. Suppose our complex number is x plus I y. It has real part is x and we will draw this x in real axis. Suppose this is x0. Again, imaginary part I y. This is 0 y. This is the point P. X, y. This is the point form of this complex number z is equal to x plus I y. Now draw perpendicular from the point P upon x axis. Let n be the foot of the perpendicular and the height or length of this perpendicular be y. This is also called ordinate. And OL, this is x. Right? If we join OP की जो join कर this is the hypotenuse and its value becomes root over of x square plus y square. This is also called modulus of a complex number. Modulus of a complex number. So denoted as mod of z is equal to root over of x square plus y square. X square plus y square whole root over. This is the modulus of a complex number. So we will discuss about the trigonometric form. Let the angle that the line OP makes with real axis be theta. Measured in positive direction, that is anti-clockwise positive direction. This is theta. In the right angle triangle OMP. In right angle triangle OMP, can I write tan theta is equal to y by x? ठीक है जी? Tan theta is equal to y divided by x. Then what is the value of theta? Theta is equal to tan inverse y divided by x. And this theta here, this theta is called amplitude of the complex number or argument of the complex number. Theta called argument of amplitude of Z, complex number Z, denoted as argument of the complex number Z is equal to, that is theta, and whose measure is tan inverse y by x. So we will discuss about this argument later. First, come to the trigonometrical representation of x and y. So in the right angle triangle OMP, right? What is the value of sin theta? The value of sin theta is equal to, that is p by h, y divided by h. Our h is root over of x square plus y square. Let us denote this root over of x square y square as r, that is y by r, that is equal to r. That implies the value of y is equal to r sin theta. Again, cos theta is equal to x by r. That implies the value of x is equal to r cos theta, right? So now we have the values of x and y. So the complex number z is equal to x plus I y can be written as r cos theta plus I into r sin theta. By taking common r, we have cos theta plus I sin theta. This is the trigonometric form or polar form of the complex number z is equal to x plus I y. And here this theta is called argument of the complex number, and these are two values. This theta have two values. Number remaining values. So general values, for general values, we can take 2n pi plus theta. 2n pi plus theta. Principal value. When we take or limited theta, that is greater than minus pi, less than equal to pi. When you take theta between minus pi to pi, so in this case, this theta is called principal amplitude. This is called principal amplitude. General amplitude, there is 2n plus theta, 2n pi plus theta, and principal amplitude, principal value will be measured between minus pi to pi. Right? So let us take an example. Suppose our given complex number is 1 plus I. Now write this complex number. We have to write this complex number in polar form or trigonometric form. So let its trigonometric form be r whole into cos theta plus I sin theta. Right? First we have to calculate theta. First we have to calculate r. R is equal to whole root over of x square plus y square. This is equal to whole root over of the value of x is 1, square of 1 plus the value of y is also 1, that is square of 1. This is equal to root over of 2. This is the value of r. or modulus of the complex number. So that is root over of 2. Then theta. What is theta? Tan inverse of y by x. This is equal to tan inverse, the value of y is equal to 1 and the value of x is also equal to 1. That is tan inverse of 1. This is pi by 4. The value of theta is equal to pi by 4. Right? So now the polar form of z or 1 plus I is root over of 2. We will write root 2 in place of r whole into cos the value of theta is equal to pi by 4 plus I plus I into value of sine into value of theta is also equal to pi by 4. So this is the polar form or trigonometric form of the complex number 1 plus I. Similarly, let us take another example. What is the polar form or trigonometric form of root over of 3? What is the polar form or trigonometric form of the complex number root over of 3? Now, this is our given complex number root 3, and the standard form of this complex number is root 3 plus I into 0. Here our x is equal to root 3 and y is equal to 0. Now we have to calculate r. R is equal to root over of x square plus y square. This is equal to whole root over of x square, that is square of root 3 plus square of 0 is equal to root over of 3. Square of root 3 is 3 plus 0 is equal to whole root over 3. This is the value of r. Then come to theta. Theta is equal to tan inverse y by x is equal to tan inverse, the value of y is 0 and the value of x is equal to root 3, that is 0 by root 3 is equal to tan inverse 0. So is equal to 0. There our amplitude is equal to 0. Our argument of the complex number is equal to 0. Now the polar form of the complex number root 3. Formula is r whole into cos theta plus I sin theta. That is the value of r is equal to root 3 whole into cos. The value of theta is equal to 0 plus I into sine, the value of theta is equal to 0. This is equal to root over of 3. Now finish. Sorry बता आगु कैलकुलेशन बोले पुणे हमें एक कॉम्प्लेक्स नंबर रूट 3 को पढ़े आसे रियल नंबर को पढ़े आसे. So root 3 into cos 0 plus I sin 0. This is the polar form. So in this way we can represent a complex number in trigonometric form. In our next session we will briefly discuss about the amplitude or argument of a complex number, because we have taken only first quadrant tan inverse y by x. This section we only first quadrant neechu, but there are other quadrants also, second, third, fourth quadrant. In different quadrants, what are the argument or what is the value of theta in different quadrants we will discuss in our next session. Thank you.